Welcome to classification of matter. So matter is anything that has mass and occupies space, and we have four phases of matter: solid, liquid, gas, and plasma. So solid, of course, has a fixed volume and fixed shape. If we have some solid, let's say a table, it's got some fixed volume. We can't, by pressing on it, by exerting some pressure on it, we can't change the volume of that table significantly. And we can't change the shape of that table without breaking it. Whereas for something like a liquid, it has a fixed volume, but it has a variable shape. I can pour water into a different cup, and it will take on the shape of the cup, but it still has the same volume. If I have one cup's worth of water, and I pour it into a different shaped cup, it still has the volume of one cup, or liters, or whatever the volume is. Gases, on the other hand, have variable volume and a variable shape. They expand to take up the available volume. So if you have an open container, they'll leave the container. Plasmas have a variable volume and variable shape. They're basically gases that have been ionized. So they're composed of charged particles, positive and negatively charged particles. So we have a couple of different divisions of matter. We have pure substances, which are a pure substance is a substance with a fixed composition. And so this is something like an element or a compound. So elements are substances that are composed of just a single type of atom. We can't decompose them into simpler substances by chemical or physical means. The elements are also listed on the periodic table. There are only roughly 118 of them, depending on when exactly you're watching the video. There may have been another one discovered by then. Compounds, on the other hand, they're still pure substances, but compounds are composed of multiple types of atoms, so multiple elements linked together. So these can be decomposed into simpler substances by chemical means, but not by physical means. So physical means are something like physically moving things apart, or using a magnet, let's say. If I have a mixture of sand and iron filings, I can separate them physically by waving a magnet over the mixture. The sand, of course, won't be attracted to the magnet. The iron filings will, and so I can separate it physically. But with a compound, if I have something like water that's composed of hydrogen and oxygen, two hydrogen atoms, one oxygen atom, I can separate those, but I have to do it chemically. I have to break apart that chemical bond between the hydrogen atoms and the oxygen atom. So I can still do it. I can separate water into its component elements. I can do this by passing electricity through, which is how our sailors survive in nuclear submarines. The nuclear power plant generates a lot of electricity, and we use a portion of that electricity to split the water molecules apart into oxygen molecules and hydrogen molecules. The hydrogen gets pushed back out into the seawater, and the oxygen gets distributed throughout the boat so that the sailors can breathe. So we have pure substances, which are elements and compounds, and then we also have mixtures. And a mixture is a substance with variable composition. So where a pure substance had to have a fixed composition. So if we have, say, aluminum foil, all of the atoms in there are aluminum atoms. If we look at the chemical formula for the aluminum foil, it's just aluminum. If you take any portion of it, 100% of it, or almost 100%, will be aluminum. There may be some impurities. If we have a compound like water, well, we have two hydrogen atoms, one oxygen atom. If we change that ratio, if we have, say, two hydrogen atoms and two oxygen atoms, well, now we have hydrogen peroxide. That's a different compound. We don't have the same stuff anymore. But with a mixture, like with my sand and iron filings, there's no inherent required mixture composition that we have, right? I could have a cup's worth of sand and one iron filing, or a cup's worth of iron filings, or 10 cups of iron filings, or all the iron filings on Earth. I can vary that ratio between sand and iron filings, and so that's a mixture. Now we have two different types of mixtures. We have homogeneous mixtures and heterogeneous mixtures. So genius means type, homo means same. So a homogeneous mixture is composed of things that are all the same type. So it has no visible differences in its parts. So this is something like sweet tea with no ice in it. Because if you take out a spoonful of the top and the bottom of the mixture, they're going to look the same. Any 2 spoonfuls of sweet tea, suitably mixed, will be exactly the same, at least to our eyes. Something like milk from a store. Now, milk directly from the cow is not homogeneous, because if you let it sit for a while, it will separate out into the fat, the cream that sits on the top of the bucket, and the milk that's at the bottom. But milk from a store has been homogenized, so it won't separate like that. Tap water is a mixture. Well, the water that you get out of the tap has other things dissolved in it. It's got some fluoride, probably. It's got some nitrates, maybe. So it's not totally pure water. And actually, as humans, we like it that way. Totally pure water, if it only has water in it, water molecules, it doesn't taste very good. Largely because it doesn't have a taste. Water doesn't have a taste. We can't taste it. Air is a homogeneous mixture. It's made up of mostly nitrogen. It's about 80% nitrogen, roughly 20% oxygen. Not quite. So there's about 1% other stuff. So those are homogeneous mixtures. Now hetero means different, so heterogeneous means different types. So this means that we can see visible differences between the parts of the mixture. So this is something like sweet tea with the ice. So there we can see visibly a difference between the sweet tea part, the liquid part, and the ice, the frozen water molecule part. And the composition of those two is significantly different. The water is, or the ice rather, is mostly water. There aren't any of the sugar molecules or the tea molecules in the ice, whereas there is the sugar and the tea dissolved in the water of the sweet tea. Another example is a salad. In a salad, we have some lettuce and tomatoes and croutons and salad dressing, maybe. And so in that salad, we can see different parts. And more than that, we can vary the mixture. I don't necessarily have to put tomatoes in. If I don't like tomatoes, I don't put tomatoes in my salad. But you may. You may put more croutons or a different salad dressing. In your sweet tea, you may put more sugar in, or you may let the tea steep a little bit longer. And so we can vary the ratio of these things. In sand is primarily composed of silicon dioxide, but there are some other impurities in it that give it the color that we typically associate with sand. If you look at the sandy beaches of some of the beaches in Hawaii that have black sand, the composition of that sand is, of course, very different from the composition of the sand here on the coastal regions in South Carolina. So sand is a heterogeneous mixture. You can see the difference. If you pick up a handful of sand, you'll see some particles, some of the sand grains are a little bit lighter in color, some are darker in color. So there are some differences there. So mixtures can usually be separated by physical means, by which we mean filtration, distillation, chromatography. If I have a mixture of sand and water, I can separate the two of them by filtering. I can pass them through some sort of filter. I can do this on a larger scale if I have, say, normal M&Ms and peanut M&Ms. The peanut M&Ms are a little bit larger, so if I have some holes that are larger than the size of the normal M&Ms, regular M&Ms with no peanuts, but smaller than the size of the M&Ms with the peanuts, if I pass the two types of M&Ms, the mixture, over a screen containing holes of that size, well, the normal M&Ms will fall through and the peanut M&Ms won't. So I can separate it by filtration. We can also use distillation and chromatography. So distillation is when we heat up the mixture and use a difference in boiling points between two or more components to separate out the more volatile from the less volatile components. And we can also use chromatography, which uses, it passes the medium over some other substance that holds on to the different components at different rates. So if one component is held onto stronger than the other, then it will move along down the chromatography column slower than one that isn't held onto as well. So note that mixtures can also be separated by chemical means, but we don't have to use chemical means, right? So this isn't always practical. If I wanted to separate out, say, iron filings from the sand, well, I could dissolve the iron in an acid and then precipitate out the iron in some second reaction, but it's not necessarily practical to do. It's a lot easier to just pass a magnet over the sand and iron filings mixture and get the iron out that way. Okay, so here we have a little diagram showing that everything is composed of matter. So then we ask a question, is that substance, is that matter, does it have a variable composition? If yes, then it's a mixture. If no, then it's a pure substance. If we said yes, then we ask, does it have visibly distinguishable parts? Can we see differences in it? If yes, then it's a heterogeneous mixture. If no, then it's a homogeneous mixture. If we said no, it didn't have variable composition, it had a fixed composition, it was a pure substance, then we ask, does it contain various types of atoms? If we say no, then it's an element, it's composed of atoms of that one element. If we said yes, it contains various types of atoms, contains two or more types of atoms, then it's a compound. It's made up of molecules with more than one type of atom in them. We can convert between the two of these using chemical methods. We can convert between these two using physical methods. We can convert from here to there using physical or chemical methods. So that was the classification of matter.